Hi, this is Ruyi Zhang from Electrical and Computer Engineering Department of University of Florida. This is a presentation of a course project, pattern recognition. My project is spectral clustering for image segmentation. In this project, my primary goal is to learn more about pattern recognition, especially in the method of machine learning. I try to use machine learning to do pattern recognition and realize the spectral clustering for image segmentation. To be more specifically, the goal of this project is to separate overlapped circles and show them in different colors. Next, about the major technique and tools we'll be using in this project, they are clustering. To be more specifically, we are using spectral clustering. And what's more, we are going to use image segmentation, Python, and scikit-learn. For clustering has a long history. In the last 10 more years, more people see the significance of it. It is not only one of the important researching areas in data mining and pattern recognition, it is also the base of a lot of image processing and other applications, such as voice recognition, letter recognition, and shape segmentation. What's more, clustering is now influencing areas like biology, psychology, geology, marketing, and so on. And among all the applications of clustering algorithm, I chose image segmentation for this project. Because it is more advanced application of machine learning, and through the process I could also learn more about Python. And about image segmentation. It is the basic of image processing and pattern recognition. A lot of advanced applications are built upon it. Because of the reasons stated above, I choose this topic as my course project in order to learn more in this area and practice my ability as well. Now, what's the definition of clustering? Clustering is the process of trying to classify physical or virtual objects into groups. Every group is composed by similar objects, but objects from different groups are different. Let's see this example. We can see that there are three different clusters, cluster 1, cluster 2, and cluster 3. Each of them are separate from each other, however objects inside the clusters are similar to each other in location. This can be treated like an abstraction of some realistic problems, like the height and weight of employee in a company and something like that. Then we can see this is the formula presentation of clustering. So what is the process of clustering? The process of clustering can be classified into data preparation, feature selection, feature extraction, clustering, and evaluation. In the process of data preparation, we need to standardize the data and possibly decrease the dimension of the data in order to simplify the problem. In the process of feature selection, we need to choose the most efficient feature of the object and store them in a vector. After the feature selection, we need to extract the selected feature and transfer it into some new feature that is easier to recognize. Then we need to choose an appropriate distance function to measure the distance between the selected features of each object and do the clustering work using the chosen distance function. At last, we need to evaluate the result of the clustering work. There are mainly two kinds of ways to evaluation, which are internal evaluation and external evaluation. And after talking about the process of clustering, now we are going to talk about classification of clustering. There isn't any clustering algorithm that can solve all clustering problems for now, so we need different kind of algorithm to solve all different kind of problems with different kind of data structures. The clustering algorithm can be classified into structural or non-structural clustering methods. Structural methods are methods that can be computed both from top to bottom and the other way around. Top-down means we see each object as individual cluster and merging similar clusters. And bottom-up means we treat all objects as one big cluster and separate them gradually. Also, the clustering algorithm can be classified as connectivity-based clustering, also called hierarchical clustering, centroid-based clustering, distribution-based clustering, density-based clustering, and other methods. Distance mirroring is an important part of clustering, as we mentioned before, and there are a lot of methods to mirroring the distance between two objects. Average, centroid, complete, single, and walled. I'm not going to go to detail in the presentation, but I have the formulas in the report. Now, after talking about clustering, I want to talk about image segmentation, which is also an important part of my project. Image segmentation is a process of partitioning a digital image into multiple segments. What do we mean by multiple segments? We mean sets of pixels, also as known as superpixels. The goal of image segmentation is to simplify or change the form of the image and make it easier to understand and analyze. Every segment has its own feature. Image segmentation is the key part of upgrading from image processing to image analyzing, and it can also applied in a lot of applications, including machine vision, medical imaging, object detection, traffic control, and so on. We can see from this picture, this is an example of image segmentation. This is a segmented femur. It shows the outer surface, they're red. The surface between compact bones and spongy bones, which is green, and the surface of the bone marrow, which are blue. There are all kinds of methods of image segmentation, and they can be classified in the following classes. We have threshold-based segmentation, area-based segmentation, edge-based segmentation, neural network-based segmentation, and clustering-based segmentation. The first three ones are traditional ways to do the image segmentation, and the neural network technique has attracted a lot of attention and been applied in image segmentation from 1998. It required a lot of training data, but it can also solve the uneven and noise problems in image. But the strategy we're going to use in this project is clustering-based segmentation. So this is the threshold-based segmentation, and this is the formula of it, and this is an example of Lena to do the threshold-based segmentation. Threshold-based segmentation is a gray-based image segmentation. It is most commonly used algorithm. So suppose F is the input image, the original image. Threshold algorithm transfer it to G, like the picture said. As we can see from the above formula, the most important part of this algorithm is to decide the threshold T. So the advantage of this method is that it's easy to compute, it's very efficient, and it's very fast. And due to these advantages, it is a better choice for applications which requires computation efficiency. So about edge segmentation, it is based on edge detection technique. Due to the sharp change as gray value of this image, we can detect the edge of the image. A lot of different methods can be used to detect the edge, such as Sobal, robots, and Pewitt, Laplace, and Kirsch. So now what we are seeing is an example of clustering image segmentation. We try to use it to do the image segmentation. First, we need to map all the pixels of the image to their corresponding feature space. Then we do the clustering work in the feature space. At last, we need to map the feature back to the image. K-means is usually used in clustering method. The algorithm is stated as first we need to choose K objects from all the N objects. In this case are K pixels as an initial cluster center. Second, for all left pixels, we assign them to their nearest cluster according to their distance to all the clusters. Third, we calculate the new cluster's center, then keep doing the second and the third process until the cluster does not change anymore. These two figures are using K-means clustering. So in this project, we will be using scikit-learn of Python to do the image segmentation work. It is easier for us to use the tool Anaconda, which is a freemium distribution of Python and R programming language for large-scale data processing, predictive analytics, and scientific computing that aims to simplify package management and deployment. So it is good to know about the language we are going to use before we actually use it. We know Python has three important features. There are uncompiling, dynamic types, and whitespace. Uncompiling means you can type something right into the shell and run without any compilation work, which makes it really rapid and a prototyping language. The disadvantages of this feature that it makes Python a little bit slower. And about dynamic type means there's no strict variable types. A variable can be assigned to different types in different places at different times, and no error will occur. And the whitespace language means that, unlike a lot of other languages that are delimited by semicolons or other symbols, Python is delimited by space. What's more about Python? Python is a widely used high-level, general-purpose, interpreted, dynamic programming language. When designing Python, the programmer wants to make the code more readable and make it possible to realize their aimed purpose in as few lines as possible, especially compared to C++ and Java. Python may be described as script language, however, it is not like script language, which are aimed for small-scaled program, while Python can be used in both small and large-scale programs. Python has wide range of applications from web to GUI development to operating system. Python is really good. So, using the techniques I introduced before, we do the image segmentation using spectral clustering, and we do this project using scikit-learn of Python, and this is the result. First, the picture on the left is the original pictures, which are overlapped circles with noise, and the right one is the clustered ones. We can see the circles are emphasized and the noise are delimited. And this is another example of similar progress. Those are 2 circles instead of 4. And after doing this project, I have some future plans. For further research after this course, I'm willing to further the project to other shapes and combine shapes together, and maybe something like more complicated, not just shapes. So that's all for my pattern recognition course project presentation. Thanks for watching.